All right, and welcome to absolute value, level 1. Now, number 1 says find solutions to the function f of x equals absolute value x minus 5, where f of x is equal to 3. Okay, so let's kind of take a look at the graph of this function. So where f of x is equal to 3. Now remember, f of x is just another way of saying y. So here's our y-axis, and if I were to draw a line going across this way, well, check it out. We would be saying that our function is crossing that line at f of x equals 3, where x is equal to, looks like 2, and where x is equal to, appears to be 8. Alright? So, if we solve this function correctly, we should get out the answers 2 and 8. And let's find out if that's the case. So we know that f of x equals 3 really means that f of x is 3. And so we can write this. 3 is equal to the absolute value of x minus 5. Now notice, what did we do in our previous video, the intro to absolute values? Whenever we had the absolute value bars by themselves, we actually changed this singular term into both a positive and a negative. Why is that? Well, we don't know if what is inside in here is either positive or negative, and essentially that gets applied over to there. So what we say is that x minus 5 could equal positive 3, or x minus 5 could equal negative 3. We don't really know which it is, but we know that these absolute value bars turn both a positive 3 into a positive 3, and these absolute value bars turn a negative 3 into a positive 3. And so we actually have to solve this for both accounts. Well, x minus 5 equals 3. The opposite of minus 5 is plus 5. And we get x is equal to 3 plus 5, which is 8. Oh, wait a second. That worked out. We have x minus 5 equals negative 3, so we add 5 to both sides. That cancels out. And negative 3 plus 5 is 2, and check it out. There we go. So, what are we really saying here? Whenever we have absolute value bars by themselves, we always take what's on the right side and set it equal to the positive and negative version. All right, let's move on to a second example. Okay, for number 2, find the solutions to the function f of x equals the absolute value of 6x, where f of x is equal to negative 2. Well, remember guys, f of x is another way of saying y, and so on the y-axis at negative 2, we're asking where does this function cross the dotted line? Now you'll notice something. It doesn't. This would in fact imply there's no solution. And why is that? Well, if we set f of x equal to negative 2 and say negative 2 is equal to the absolute value of 6x, recall that an absolute value can never equal a negative. Alright? It can never equal a negative. And because it cannot equal a negative, we have no solution. Alright, let's move on. Okay, example 3. Find the solutions to the function f of x is equal to the absolute value of 3x minus 2, where f of x is equal to positive 4. Okay, so here's positive 4. Notice our graph does cross, so we probably will have a solution. And notice here it's a whole number. It's the value of 2. However, here it's not a whole number. And so this is something that we would have to solve for algebraically to know the exact answer. So f of x is 4. We set f of x equal to 4. We have the absolute value of 3x minus 2. And from here, what can we say? Well, we know that anytime we have something in the absolute value, we don't know if this is actually equal to positive 4, or is this actually equal to negative 4. We know that both of them will pop out to be positive 4, and so let's go ahead and set it equal to both. 3x minus 2 is equal to negative 4, and I'll do the other one down here. 3x minus 2 is equal to positive 4. Well, I, of course, add 2 to both sides. This is just easy solving. I promise you guys know how to do this. Negative 4 plus 2 will be negative 2. We divide both sides by 3, and x is equal to negative 2 over 3. Okay, here on the right side, we have 3x minus 2 is equal to 4. We add 2 to both sides, and we get 3x is equal to 4 plus 2 is 6. Of course, we divide both sides by 3, and we get x is equal to 6 divided by 3 would be 2. Well, that checks out for that solution, and it turned out that this one was, in fact, negative 2/3. All right, perfect. Let's move on to our next lesson.